Hi, welcome to Maheshwari Chemistry classes. Once check this all important questions. Okay, so it's only for revision purpose. So I want to tell very fast. Please like this video and subscribe my channel Maheshwari Chemistry classes. Listen carefully, beta. First question is Coolidge law. What is this, beta? At infinite dilution, the equivalent conductance of electrolyte is equals to the sum of cations and anions. Write down this equation, and after that applications of Coolidge law, you write 5 applications. One is calculation of molar conductivities, okay, with the help of acetic acid, okay. At the same time, molar conductivities of weak electrolyte, at the same time equivalent conductivities of weak electrolyte, okay. And third calculation is the degree of dissociation, alpha equals to capital lambda m power c by capital lambda m power infinity 2, and dissociation constant k equals to c alpha square by 1 minus alpha. Next, fourth application is we can calculate the solubility. Solubility equals to k into 1000 by m. Here m molarity. You may take any kind of concentration. So it is for 4 marks purpose. This Coolidge law application is a 4 marks purpose. It is a combination question for LAQ. And after the Coolidge law, one more 4 marks purpose. Okay. So write about the molecularity and order of reaction. Okay. Order nothing but sum of concentration power terms. Molecularity nothing but number of molecules of atoms or ions participating in elementary reaction. Okay. Determine here order determine experimentally. Molecularity determines the through reaction mechanism. Okay, so here order 0, negative, fraction, whole number may be possible, but molecularity not be 0, not be fraction. And order purpose applicable only for elementary as well as complex reactions. Molecularity applicable only for elementary reactions. Okay, next this one also compulsory you have to write, beta, then only you can get full marks. Okay, so bimolecular reaction purpose, hydrogen and chlorine both are react with each other and forms the HCl. Trimolecular gases reaction purpose, 2NO plus oxygen is gives rise to 2NO2. Here 1 plus 1, that is a molecularity 2. Here 2 plus 1, that is a molecularity 3. Okay, this is one LAQ over. What is the LAQ, beta? Write about Coolidge law and its applications, and write about molecularity order of reactions. Okay. And second important LAQ, collision theory or Arrhenius molecular collision theory. Already I explained in the classroom. It was proposed by Arrhenius. Okay, so bimolecular gases we have to take, both are in spherical shape and involved in the collision and give the product, but all collisions not need a product formation. Okay, so which contain threshold energy, those are only will give the product. According to that, if the molecules may not have threshold energy, we have to add extra energy. That additional energy is known as activation energy. Activation energy EA equals to ET minus ER. EA nothing but activation energy, ET nothing but threshold energy, ER nothing but normal molecules containing energy. Okay, this is the graph between energy and reaction process. Threshold energy containing molecules, okay, will give the collide. I mean, those are involved in the collision and those will give the product. Which molecules contain threshold energy, those are only involved in the collision and gives the product. Here rate of reaction ZAB into e power minus EA by RT. ZAB collision frequency. Next, EA by RT is a fraction of molecules with equal energies. Okay, according to the probability factor, P into ZAB into e power minus EA by RT. Along with the threshold energy, proper orientation also compulsory for the product. Okay, along with the threshold energy, what we require, beta? Proper orientation. Okay, in this methyl bromide react with the OH minus nucleophile. In the Br minus place, OH is substituted. That is why it is nucleophilic substitution. But direct this side is not possible, so it will attack back side. So direct this side is the improper orientation, no product. Back attack will give the product. This is the proper orientation. Here we have to write the transition state. At a time bromine elimination and OH minus attack, both conditions present. That is why it is a transition state. And finally, in the place of Br minus OH is substituted, complete opposite direction. That is why it is back attack product. Yes, this is about collision theory. Next, LAQ from organic chemistry, learn about the diazotization reaction, beta. Aniline in presence of sodium nitrate and HCl, it will give the benzene diazoxide chloride and NaCl and 2H2O. And Williamson ether synthesis is also very important. Sodium ethoxide react with ethyl iodide and forms the diethyl ether, and sodium iodide is eliminated. And decarboxylation also once you check. Okay, so sodium carboxylate react with the sodium hydroxide and the calcium oxide. Okay, so here COO eliminated with these NAs and the sodium carbonate. These R is react with the hydrogen. Okay, so it forms the alkane. Alkyl is converting like here alkane. Which alkyl beta? Sodium carboxylate. Okay, with sodium carboxylate, alkyl sodium carboxylate modified as alkane. Okay, here carbon dioxide eliminated. That is why it is known as decarboxylation reaction. Okay, so that's it. Here also CO2 eliminated, same as the CH3 is formed, means alkane. Once you check this decarboxylation, after that this diazotization also over, right? And it is one more important question as a SAQ. A solution of glucose water is labeled as 10% weight by weight. What would be the molarity of solution? 10% weight by weight glucose solution means 100 grams of solution contain 10 grams of glucose, means 90 grams solution, 10 grams of glucose. Okay, weight of glucose is 10 grams, weight of water is 90 grams. Okay, then weight of solution how much beta? 90 ml. Here 90 grams nothing but 90 ml we have to take water. Then we have to calculate the molarity. Already you know very well molarity formula. What is that? Weight by gram molecular weight into 1000 by V in ml. Okay, so we have to substitute all the values. Weight of that solute is 10 grams, 10. Okay, this solute is glucose, right? That glucose molecular weight 180, 10 by 180 into 1000 by how many ml beta water? 90. That is why 1000 by 90. If you do this molarity, you may get 0.617 moles. Okay, it is also important for 4 marks. And next important question, what is blister copper? Why is it so called? Okay, it is the copper obtained after besmerization of matte dissolved in sulfur dioxide escaped out producing blisters on the metal surface, so it is called as blister copper. It is 98% pure copper. Okay, next one more important question is calculate spin only magnetic moment of Fe2 plus ion, Fe3 plus ion, Mn2 plus ion and Zn2 plus ion. In classroom already I said to you 3D series purpose you have to remember beta plus 2 oxidation state purpose. So here one of the example I gave. Remember Fe2 plus, Fe3 plus, Mn2 plus, Zn2 plus, these 4 you once you check as a VSAQ only. Okay, spin only magnetic moment formula mu equals to under root n into n plus 2. Okay, Bohr magnetons units also you must write. N equals single electrons number. Here Fe2 plus purpose we have to write electronic configuration. So Fe2 plus purpose 4s0 3d6. Actually Fe is a 26 element, right? 4s2 3d6 will come. But here Fe2 plus means 2 electrons lost from the s orbital. The d orbital have these 6 electrons. In this 6 electrons 4 are the single electrons. We have to substitute these 4 value here. Finally we may get 4.9 Bohr magnetons. Already I said to you how many single electrons are there, equal number of Bohr magnetons, approximately same value will come. Okay, so this is about iron spin only calculate formula. Okay, how much the value beta? 4.9 Bohr magnetons. Next, once you check molarity formula, number of moles of solute dissolved in 1 liter of solution is called molarity. Simple, 1 liter solution containing solute moles number is known as molarity. Molarity units are moles per liter. Okay, molarity equals to number of moles of solute by V, nothing but volume. So finally we have the molarity formula, weight by gram molecular weight into 1000 by V in ml, right? Next, one more important question beta, what is roasting and calcination? This topic is from metallurgy. Please like, share, subscribe my channel Maheshwari Chemistry Classes. Please give me your support beta. So already it is too late and you don't have time, that is why I am telling very fast. So please excuse me. Roasting, the process of heating. Calcination, it is also process of heating. Roasting, in presence of oxygen we have to heat below its melting point. Okay, calcination, process of heating but in absence of oxygen below its melting point. You remember this point. Roasting is useful for the sulfide ores. Calcination is useful for the carbonate ores. Roasting is useful for the, what is that? Sulfide ore roasted to get oxidized. Here calcination, carbonate ores are oxidized. Okay. Here a roasting purpose, ZNS, more amount of oxygen purpose. It is involved in the oxidizing roasting, ZNO and sulfur dioxide gas eliminated. Okay. And zinc sulfide in presence of oxygen, okay, at 923 K it convert like a zinc sulfate. It is sulfatizing roasting. Okay. So here impurities are eliminated as a sulfur trioxide and arsenic trioxide. It is extra point, useful for MSET also. Next, calcination purpose. Calcination especially for what purpose beta? Carbonate ores. Calcium carbonate, when we heat, calcium oxide and carbon dioxide is released. Magnesium carbonate, when we heat, magnesium oxide and carbon dioxide gas is released. Here which impurities are eliminated? Water and organic compounds are eliminated. This is about roasting and calcination. It is also important for 4 marks. Okay. Next important question, Froth flotation method beta. In this Froth flotation, what we are concentrating? Sulfide ore is concentrating. Especially here we are using a suspension of powder ore. What we are taking? Powdered ore we are taking. It is mixed with the water. After that stabilizers. After that Froth floating agents. After that collecting agent. What are the stabilizers beta? Cresol and aniline. Froth floating agent is the lime and sodium carbonate. And collecting agent is the sodium ethyl xanthate. Okay. All these are mixed with the help of rotating pedal. This is the rotating pedal. And it air also inlet inside. That time what happens beta? Finally froth is this is a froth there na noraga. Okay, froth is top side and gong is down side. Okay, so these froth we have to skim off, then we can dry it. Like that, what we are separating beta? Sulfide particles. Okay, especially sulfide ore is separated. Sulfide ore is concentrated, especially PBS and ZNS. This is also very important question beta. Check it properly. Next 4 marks question, SAQ, Werner's theory. Postulates of Werner's theory, especially it explains about the primary and secondary valence of the coordination compounds. Who explained beta? Alfred Werner, scientist. Okay, and directly write down these 5 points for this primary and secondary. Primary equal to the oxidation number of central atom, indicated with the dashed line, and it is satisfied by only negative ions, and it is ionizable, non-directional, and it not predict the shape. It is complete opposite to the secondary. Secondary valency explains about the coordination number of central atom. Okay, nothing but direct bonds, and these are indicated with the thick line and satisfied negative and neutral ligands both. Okay, next secondary valency non-ionizable means no charge, and secondary valency thick line there, that is why it compulsory give the shape, I mean it predict the geometry. Okay, so like this we have to take this diagram. Okay, so CO, Cl3, 6NH3, 5NH3, 4NH3, 3NH3. Here one structure this. Okay, here ammonias are 6, here 5, means 1 is decreased, that extra duty taken by this chlorine. Here compared to first one, 2 ammonias are decreased, means extra duty taken by these 2 chlorines. Here 3 ammonias are decreased compared to the first structure, that is why these extra duties are taken by these 3 chlorines. Okay, only it is a fast revision, that is why once you check it beta. But in external exam you may get any 2, but right now you have to write 4 structures. Okay, prepare it properly and write the IUPAC names of the systematic names. Okay, simple coordination compounds they will give. These are the very important coordination compounds. In that, some of the compounds beta, PT NH3 taken to Cl, NH2 CH3 Cl. It is a diamine chlorido, methylamine platinum 2 chloride. Okay, or else you can write directly like this. These are the very important structures beta. Once you check what is the name of this compound beta, diamine. Okay, diamine chlorido. Okay, so here amine, A will come first, C will come next, M will come next. That is why methanamine. Okay, in brackets write down. After that central metal atom platinum. Okay, 2 chloride. Next, what is the name of this beta? Here you may write down methylamine place methylamine also correct. Don't worry. Next, once you check potassium tetrachloro. Why? Because positive first, right? Potassium tetrachloropelladate 2. After that, what is the name of this one beta? Positive ion first means potassium trioxalate chromate 3. Okay. Next, what is this beta? Positive atom not there, direct given. Okay. Here, what is the name this beta for this? Once you check it, potassium not there, positive not there, mean direct central atom, and ligand there. Mean first we have to write ligands. Trioxalate ferrate 3 ion. Okay. What is the trick beta? First positive atom, after that coordination sphere, after that negative atom. Positive atom, okay, direct name, no ditri, okay, direct name. Negative atom also direct name, no ditri. Here positive first, after that ligand, after that central metal atom. This is the trick box you remember, and these are the examples once you check, especially diamine chlorido methylamine platinum 2 chloride, or else diamine chlorido methylamine platinum 2 chloride. Any name, both are correct. Next, another one is the trioxalate ferrate 3 ion. After that, potassium tetrachloropelladate 2 ion. Sorry, now it is complex, right? Potassium tetrachloropelladate 2. After that, potassium trioxalate chromate 3. Okay. Please like this video beta. Remaining questions I can upload in next video. Thank you. Please like this video and subscribe my channel Maheshwari Chemistry Classes. Thank you.